Alright everyone, this is the video to walk us through the first 5 questions of exercise 8H, which is what is the work for this week. Okay, so firstly let's read the first part of the question. That'll help us understand the graph. A new piece of equipment is purchased by a business for $150,000. The value of the equipment V in thousands of dollars. That's where the first error in the textbook is. That shouldn't be D, that's V. And these are in thousands of dollars. Depreciates, which means that the value is getting less and less. So we've got a downward trend in the graph. And each year in T, so these are years. Draw a number plane as shown opposite. So they've got it for us. Please remember that when you're drawing a graph, 2 things. Firstly, the top row goes along the horizontal down the bottom here, and the bottom row is this vertical, and the values should be able to fit in all the values here. So you've got to do a scale that fits all of these values inside it. Okay, let's plot the points. I'll use red. There we are. So 0, 150, 0 years at the start, and that's where, here it is, 150. That's what the equipment cost to start. After 1 year, it's only worth 75,000. 1 year, 75, that's there. 2 years, 38,000. 38 is just below 40. 3 is 19, 4 is 9, 5 is 5, and 6 years it's only worth $2,000. Plot the points, join the points. Let's join the points. And we see pretty clearly that it's not a straight line depreciation, it's a curve downwards, gradually working our way down that way. So that's part A done, part B done. Part C we're going to do over here. An exponential model, so this is an exponential graph going downwards. Is the form of y equals 2 to the minus x times a. So that's this one. What is the model if x and y are replaced with t and v? So x and y replaced with t and v. So y is replaced with v. So put v equals, instead of y equals, 2 to the minus x is replaced with t times a. That's C part 1. C part 2. Determine the value of a using the model, in the model by using t equals 0. Okay, well when t equals 0, v is 150. So we need to know both of those so we can work out what a is. So instead of v, we'll put 150. 2 to the minus 0, because t equals 0, times whatever a is. Now, 250 equals, well, all of this, 2 to the minus 0. All of that just equals 1. That becomes 1 times a. Well, now we've worked out, well, okay, looks like a is 150. That's the answer to part 2. Part 3. See, part 3. What is the exponential model using t and v? So now we're going to put all this together. We've got v equals, that covers every value of v, 2 to the minus t times, so now we know days. 150. There we go. Answer part 3. D. Yep, we'll do it over here. Use a model to predict the value of the equipment after 2.5 years. All you do is put 2 to the minus 2.5, 2.5 years, times 150. You put that on put all this in a calculator, you'll get our answer. E, basically the same as D, except this time 6 months is half a year, so 2 to the power of minus 0.5 times 150. Put that in a calculator, you'll get the answer for that one. And F is a dumb question because the value of the equipment, when will it be 75,000? After 1 year. 1 year. I don't know why they put that. Use a model to predict the value of the equipment after 20 years. So with G, same again. 2 to the minus 20 this time for 20 years times 150. You put that in a calculator, you get your answer. Okay, that's question 1. Question 2, we'll spend a bit less time now we've done the first question. Plot the points, find rotated values. Notice top row becomes down here and it fits 1 to 6. And we've got a distance an object falls in t seconds. So now t is in seconds and that's distance. And so plot the points, join the points. That's quite easy. 0, 0, 1 and 5 and so on. So 6 you'll get up to 180. Part B is what we'd come across before with the previous question. I'll just go through that in detail. So I'll do it over here. B, part 1. X and Y are replaced with T and D. Y is replaced with D. X is replaced with T squared. There's that one. That's part 1. Part 2. Value of A using T equals 1. T equals 1, D equals 5. 5 equals A times T. Oops, sorry, forgot. We know what T equals. It's 1. That's what it says there. T equals 1. A times 1. 1 squared is 1. 5 equals A times 1, so A's got to equal 5. Part 3. Quadratic model now, so put all this together. D equals now 5 is A is 5 and T, that covers every scenario, 5T squared. Okay. Part C. Use a model to find the distance fallen after 3.5 seconds. So you put 5 times T is 3.5 seconds squared. D, model to find the distance after 10 seconds, so 5 times 10 squared. What time taken an object to fall 320 metres? So now we've got a bit of algebra. So now we've got the distance. They've told us the distance is, this is part E, sorry. Part D is pretty easy. part E, 320 equals 5 times t squared. Algebra divided by 5 gives you 64 equals t squared. And to find what, so t squared is 64. To cancel out the squared, you do the square root. So square root of 64 equals t. That equals 8. 8 seconds. Earth's atmosphere is approximately 1,000 kilometres thick. What limitations would you place on this model? Well, once you get past the atmosphere, then the rate of the distance falling is going to change a bit because of gravity. That's what that's all about. Next. Tadpoles in a pond. Number plane. Oh, they didn't draw it this time. We do have the table of values. So in your book, I started the table of values here for you. Just remember, across the top here, we're going from 0 to 14. 0, 1, 2, 3, up to 14. And up here, it starts at 0 and goes up to 1176. So I went up by hundreds. 100, 200, all the way up to 1200. So that fits all the values for t along here, and up here is n, number of tadpoles. Plot the points, quadratic model. So I've done that already with you before. So now it's your turn. So just replace x and y replaced with t and n. So n equals a t squared. Then we do the same thing of what I did before, and then you can substitute in to find what these values are. Speed of a car, s in kilometres per hour, and the time taken. Time taken, t in hours. So time is 1 hour, you've travelled 120. Speed of a car, yep. Number plane, so your values have got to go from the bottom row from 0 to 6, and up here it's got to go from 0 up to 120. Hyperbolic model in the form of y equals a over x. I'll do this one in detail. What is the model of x and y replaced with t and s? So s equals a over t. Determine the value of a. I'm using t equals 1. Well, t equals 1, s is 120. So 120 equals a over 1. A equals 120. And then put all that together, you put s equals 120, now we know what a is, over t. S over t, yep. Use a model, this model, to work out the speed of the car after 8 hours. So we'll put 8 here instead of t. Time taken for a car to travel the speed of 48. So we'll put 48 here instead of t. No, 48 here. 48 for this s. S 48 equals 120 over t, whatever t is. And predict the speed of a car after 30 minutes. Is it possible? Explain your answer. Straightforward there. Next. Investment. Draw a number plane. So value across the bottom. 0 to 5. Up this way will be 0 up to 759, so probably 800. make sure they're equally spaced, and then plot the points. Then they've done the same as before. X and Y replaced with T and A, so Y is replaced with A equals 100 times A to the power of T. Determine A in the model by using T equals 1, while A equals 100 times, well, T is 1, that makes that A. So A is 100. And the final model is A equals 100 times 100 to the power of T. The rest is straightforward. Thank you very much.